Hey guys, welcome back to another video. Today I'm going to be giving a try LeetCode 54 Spiral Matrix. This is once again as part of my raw and authentic LeetCode walkthroughs playlist, and I haven't done this problem before, I have no submissions, and I'm just going to be giving this problem a try. So this is a medium problem. Given an m times n matrix, return all elements of the matrix in spiral order. So this is the matrix. You return it in this order: 1, 2, 3, 1, 2, 3, 6, 9, 8, 7, 4, 5. Okay. 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. Okay, interesting. Let's see. Okay. We need a way to indicate. Okay. Let me think. This is kind of tricky. Okay, so I guess the first thing that pops into my mind is, when I do this, how am I going to tell it not to go up there? And say this is a much bigger matrix, say it's way further down. How am I going to tell it on the next way around that it shouldn't go into this row? You know, and like how would I set those boundaries? Or when it comes, like, say this is a much larger one, like how would I be able to tell it don't go to the bottom when you go down on this side, if that makes sense? Like, don't go into this row, just go here, and then don't go into the fourth row. How would I be able to tell it? And I think I need like pointers, or like something that indicates like you can't go down there. It's like that's like the min and the max for the y axis, and maybe something similar for the x axis. Then something else I guess would be important is like knowing which direction we're going, just to make everything. I don't know how necessary this would be. I mean, I guess it would help to just be like to have like some sort of variable that's like direction. That's like direction equals r. And then maybe I have like a dictionary that's like next direction equals equals, and it's like a dictionary. And then I have like r. And imagine if you're going right, the next direction that you go is down, something like this. And then if you're going down, the next direction is left. And then if you're going left, the next direction is up. The next direction is up. And if you're going left, the next direction is up. And if you're going up, then the next direction, which is a full circle now, would be to go right. And basically you could be like call like next direction dot, like get for that value, right? And that would like tell you the direction that you have to go next. This would just like help me kind of understand where we're at in the problem as it progresses. It would just help break down the problem into different cases and different states that I could deal with individually, right? Like, oh, if I'm going right and I hit a wall, what do I do? Oh, well, I have to go down. But that's not going to be the same as if I'm going down and I have to go left now. It's not going to be the same, right? So as I was saying, okay, I think one thing that we should have is okay, let's say this direction is the x and this direction is the y. So let's have like a variable that's like x current equals 0, and let's have y current equals 0. Okay? I'm just gonna say cur, just to make it easier to type. Then let's have boundaries. So I guess like for the x we could have x min, and I'm just gonna set this to 0 because I think that's probably the most basic way to put it. I guess just leave both of them on the outside, because really we don't want to go past, because that kind of just maybe overcomplicates things a little bit, especially since I can't really go up that way. So for x max, we want to have 3. So we want to let's get matrix 0 dot like length matrix 0 x max, yeah, and then y max is going to be length matrix, just in general. The matrix is 3 long. Okay, this makes sense. Then, okay, I was saying something about a direction. Direction is, well, we're going to start with right. We're going to start by going right. Wait, did I already say this? Oh, okay then. Here, maybe I should make some more room. I feel like this is going to be a long problem, so let's zoom out a little bit. Okay. So, okay, you know what? I think I need to draw this problem out, so I'm going to pull up my iPad real quick. Okay, wait. Let me think about this real quick. You know what? Here, I think I can just make it work just by typing it. But let's think about this. Okay. I'm gonna zoom back in just for a moment here. Okay. Let's copy. Actually, you know, let's go with the bigger matrix just because this one is not a 3x3. This is a 4x3. So let's do this just so we can see what we need to do here. I'm going to do that just so that the 4 and the 8 line up. There, okay. So, let's think about this. So what we want to do is we want to be able to say, okay, let's say our x min is right here. Okay, wait, how am I going to say min and max? I'll say, I guess I'll say x, I'll say minus or something for min, and then x plus for max. And then on this side, I'll have like y min, and on this side, I'll have like y max. So we're going to be at 0 here, right? And I guess what we could do is we could say, okay, well, okay, this is going to be the same length as all of these combined. So what I'm thinking is maybe we have a while loop and we do the entire thing under the while loop, and then we would just return our result. So we will have like a result, and it's just going to be an empty list. Oops. And then we're going to have like a matrix size or something, and it's going to be equal to length of the matrix times the length of the matrix x-axis, right? And so, okay, let's do this like walk through, I guess. So here what we'll do is, so the direction here is right. So what I'm going to do is every time I progress, I'm going to add the matrix at the current x and the x current x and y cur, and then we're just going to progress x, and I'm going to do that until x equals this value. Yeah, so when x equals this value, I'm still going to do that. I'm still going to add the 4, and then what I'm going to do is I'm going to increase y. I'm going to increase y. Okay, and I'm going to increase this. So y minus will come here. So y minus will come here. Now we're at 8, and I'm also going to change the direction to right, to down. And when I'm going down, I'm going to say that when you go down, you're adding the numbers still. You're going to add every number on every single iteration. And you're going to go down here, and it will add this too, and then it will hit the wall. And then when it hits this wall, it's going to be like, okay, let's go this way. And then I'm going to change the max. Yeah, because you've cleared this entire row at this point. So we can change x plus to like right here now. And then we're going to also change the value. We're going to reduce the y cur, or sorry, the x cur. We're going to reduce it by 1 to bring it here. And then we're going to clear this row, and then y plus is going to be here. They're both going to be on the same row. You're going to clear this row, right? You're going to go till x minus, and then you're going to go up to 5, and then at this point you've cleared this row, so then this gets shifted over. Oops. So then this gets shifted over. So now you have x minus here and x plus here, and then you clear this row, and then that should be it really after that. Yeah. Okay. Okay, I think that makes sense. Okay, yeah, that makes sense. So, sorry, I got a phone call, and I'm not allowed to make cuts. Okay, so I guess, okay, this makes sense. Okay, let's try this. I'm gonna leave this here just so I have it, just so I know how things kind of would progress throughout. But we're gonna have while, I guess, length of the result is less than the matrix size. Okay. Now I said on every iteration I'm going to add a number, right? So I'm going to add the first number that I can. So I'm going to say result dot append matrix. What part do you add first? You would say y cur and then x cur. So we're going to append this. Now we have a bunch of different cases that we want to consider. So let's consider a few right now. So we have the case where if direction equals r. Okay, we're going to have one of these for each direction now, and then that should hopefully be it. So if the direction is right, what we really want to check is if x cur, so we have if x cur equals to x max. If it does, then we change the direction to down, right? We change the direct. Okay, well I guess if I'm manually doing this, I feel like this doesn't really have much of a point. Just because even though I'm there is a set order that I'm changing the direction, the steps that I do between those are very different. You know, I'm going to be checking different things. I'm going to be updating different values. So I'm just going to get rid of this completely. And then, so direction equals down. So then what we want to do is so we're going to already have added this value. We're going to now bring we're going to bring y cur, we're going to increment it. So we're going to y cur plus or equal to 1. And also we need to have y min plus or equal to 1, right? Okay, that makes sense. Else means we're just at 1 and we're going to 2, and we're at 2 and we're going to 3, or we're at 3 and we're going to 4. This is just the case for when we're at 4 and we have to turn. Otherwise, all we do is we just simply increment x cur, right? X cur plus equal to 1. Yeah, that makes sense. Okay. Then there's the other case. Okay, I think I should say elif here, because what happens if the direction changes to D and then immediately runs this code? I'm just going to say elif because I don't know if that would cause problems, and I'd like it to just do one. Yeah, because what will happen is this will happen, and then this might run, and it'll skip a character because it only appends for each iteration. So now, if the direction is down, we'll say if y cur equals to y max, then we change the direction to left. So our direction is now going left. What else did we do here? So we changed y cur, we added 1 to it. So then we have x cur, and we're going down, we turn left. So we're going to now move here, so that means that's x cur minus equals to 1. And then, wait, I think this is capital M, sorry, right? Y, yeah, okay. So we have x cur minus equals to 1. That would bring the value down here. And then we also have to adjust x max. So x max minus equals to 1. then we have the other case, else. I think all the cases are going to be somewhat similar to this, so I'm just going to copy and paste this for the other two, and then make the necessary adjustments. So else, otherwise that means we're just really just going down, so it's just going to be y cur plus equal to 1. And now I'm just going to copy and paste this for the other two cases. Alright, I'm gonna do this just so I can see everything. Okay, so this is good. So now we have the case where we're going left. We have to now, the next direction is going to be up. How do we know? So we're going to be going left. Here would be when x cur equals to x min. Then what would happen is y cur is going to be decremented. Right, y cur incremented, x cur decremented, y cur incremented. I bet this is going to be x cur incremented here. That's probably what it's going to be. Just because the case should be pretty different for all of them since they're all going in different directions. Sorry, where was I at? We're going left, we go up. Y cur subtract x max. This should be different. We should have y max is being decremented. Right, that makes sense. And then here we decrement y cur. Wait a sec. I'm thinking of the up case already here. No, it should be x cur is being decremented. Here y cur is decremented. Yeah, because you're going up here. This is the case where you're going up. And then when you're done going up, you're going to turn right when you hit a wall. And that wall will come when y cur equals to y min. Right? Because you're going to be going up, you're going to hit the min on this side. Then what's going to happen is you're going to have x cur. Let's think. So here you're going to want to just move it in 1. So you're going to want to increment x cur by 1. That's what I said, I'm pretty sure. And then x min is also going to be incremented. Otherwise, you just decrease y min. Yeah, that makes sense. Okay, I think I understand. Wow, that is a bit of a complicated problem. Honestly, I feel like there's probably a better way to solve this, but this is kind of the first kind of most obvious way to do it, even though it seems to be a bit brute forcey, but hopefully, let's see if this works. Oh, oops. I don't know how I messed that up. Forgot to put double equals for all of the ifs. Let's see. Come on. List index out of range. Okay, real quick, I'm gonna go through and make sure that I've done all these correctly. So x cur equals to x max is when you're here. Otherwise, you're just incrementing x cur. That's perfect. The next direction is down. Y cur is going to be incremented, and y min is going to be incremented. Okay. Now you're going down. Otherwise, x cur is incremented. If you're going down, y cur is being incremented. That's perfect. If you hit a wall, when y cur equals to y max, yeah. Oh, oops. What is this? Little typo. That could honestly, let's see if that works now. Okay, okay, got my hopes up for a second there. Don't want to make sure x cur, I don't want to make any of those typos. Those can be dangerous. Okay. Okay, so if the direction is down, we're going down, we hit a wall where y cur equals to y max. Our next direction is left. X cur we're gonna increment, and the x max we're gonna decrement both of those. And then y cur, otherwise we're just incrementing y. Okay, yeah. The direction is left now. We hit a wall, we go up now. Y cur we decrement, y max we decrement. Otherwise we're just decrementing x cur. Okay. direction equals u, we're going up, if y cur equals to y min. If y cur equals to y min, yeah, direction is right. We're just going to increment x cur, and we're going to increment x min. Y cur, otherwise we're just going to decrement y cur, return result. Alright, let's think. So, okay, list index out of range. So, maybe at some point we're not updating the value right. I mean, like, that's got to be the obvious case, is we're like not updating y curve properly. But something that could set that straight is thinking, okay, maybe the value is just off at some point, and a way that we could recorrect it is basically, like, imagine we complete this whole top row. We're going to now change our direction from right to down. Let's look at that case actually. So we're going to hit the wall, our direction is going to change to down. Our y cur is going to get incremented, and our y min is going to get incremented. So why don't we just set y cur to y min, just so that we're sure it's setting to the right value. And then same here, x cur equals to x max, x cur, y cur equals to y max. Y cur, x cur equals to x min. Okay, let's see. Okay, so the index is still out of range at some points. I'm trying to think what is going wrong here. I feel like this should work. This is in the right order, right? Why is that? Yeah. Yeah. I'm not too sure. Let me think about this. So, the direction is being updated, probably everything. Y cur. Not too sure, actually. I feel like in one pass, each iteration, it should be doing the right thing here, but I'm not sure what's going on. Okay then. Let me give this some thought. I'm actually like not too sure about this. I think like the only like reasonable that like the values seem to be updating properly. It just seems to be like some like other errors happening. I don't really know. Dang, this is gonna be a long video, guys. I have to get this. I feel like I'm super close because the logic kind of checks out here that eventually it will be the same length and it will work out. But it just doesn't seem to be working out as I want it to. Hmm. Hmm. Yeah. Wait a sec. Oh. Oh, wait, I made a mistake here. Oh, I see what it is. I'm not initializing the values properly. Oh, shoot. Yeah, because this is 0, 1, 2. It's going to be 3. It's going to be out here. Dang, I even said it shouldn't be there. Okay, let's see if this works. What the heck? I should have gotten that. Okay, oh, wait, wow. Okay, wait, this actually works then. So it was just this? Oh, that's a bit annoying. I presumed it was something to do with this because, index out of range. I assumed that I kind of did these correctly, but I suppose not. Let's see if this runs now, if I submit this. Beautiful. Awesome. Looks like it ran perfectly. 100%. That's amazing. Okay, well, that was a bit of a tricky one. This is probably the hardest one that I've had to upload on the channel so far. This is going to be a bit of a longer video, but that's that question. That's LeetCode 54 spiral matrix. If you guys think you solved it in a better way, please let me know down in the comments below, and I'll be sure to check them out. But besides that, that's the end of today's video. I hope you guys enjoyed, and I will see you in the next one. Bye-bye.